Okay, here we are. Here we go, 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 here we go into another one into the books. Yeah? Okay. So again, we're talking about the abacus, and we're talking about all these things that I do with the abacus, which is kind of crazy. Okay, so what is this thing? This thing is a counting tool. This counting tool helps me count. What are we doing? We're going to be counting on the abacus. What does that mean? We're going to be doing 1, 2, 3, 4. And if you notice, we are talking about having 4, just like sumatizing. First, my just like a die. So, hey, good evening. Well, it's evening for me, so good evening, early morning, wherever you are. Welcome to my room. We're talking about the abacus, and what are we doing? We're talking about the abacus. This abacus helps me count, and what we're going to do is we're going to be adding, subtracting, multiplying, and dividing, depending on how far we get, actually, and depending on all the questions. So what we're going to be doing is we're going to count. So how do I know that this is counted? Well, if you notice, these are the beads, and what we're going to do is we're going to count on the abacus. This is an abacus. It is a counting tool. It helps me do arithmetic. Now, arithmetic is adding, subtraction, multiplication, and division. And so what we're going to do is we understand that this is the horizontal bar. This horizontal bar lets me know that this bead is being counted. Now, you'll notice that I'm actually using this bead in this over here. Now, why am I at this dot? This dot right here tells me that we're going to be in the ones place. And so because we're at the ones place, we're going to start counting. This is 1, this is 2. So now, if you notice, we have the horizontal bar, and then this is 2. Notice how easy it is to see, just like on the die, right? Let me find it, 2. Right? So on the die, it looks like 2. On the abacus, this is 2. So we have 3. On the die, we have 3. Right? And then 4 we have on the die. That's 4. How do we know? 1, 2, 3, 4. Just like on the abacus, we do 4. 1, 2, 3, 4. And when we notice is that all the beads touching the beam is counted as 4. Just like when we have the die, anything that's on, showing, that's what the number is. So it's the same thing, but notice we only have 4 beads at the bottom. This is where we start talking about positioning of the bar. Because we have the horizontal bar, we have 1 bead that's on the top. This is considered the top bead. This top bead will always have a value of 5 all the time. The value of 5. So this is 5. Right? So this is 5, this is 5, this is 5, this is 5, this is 5. If I even do all of this, these are all 5s, no matter what. They're all going to be 5. So what happens after 5? Well, we have this 6, because how do we know that this is 6? This is 6 because this has the value of 1. So because this has a value of 1, when we bring it together, when we bring the beads together, this is 6. Oh, I don't know if anybody can hear my sirens. Yeah, we get a lot of sirens from where I am. Anyways, so we have 6, 7, 8, and then 9. So we have 9. How do I know this is 9? Because we have all the beads touching. And when we count 5, 6, 7, 8, 9. So that's how we count, right? So when I take away the 5, then I have 4. If I add the 5, we have 9. But then if I do that, that's 9. Or this is 9. Or this is 9. Or this is 9. Now notice what is after 9. And if I can find my papers... Paper. How do we do 10? 10 is just the way we write it. And if I can find my paper, it'd be nice to visualize. But I can't find my paper. So I will have to write it out. I will have my trusty workbook. Can I have my workbook? Okay, where's my workbook? Sorry. A little disorganized. I have a lot of paper and books and stuff. Okay, never mind. You know what? I'm just going to use paper. So, let me go to a new page. I should have been a little bit more prepared. Oh, you know what's right here? It's right here. I found it. Let's go. Okay, so what do we mean? Now, okay, we did 1, right? We did 1. We did 2, we did 3, we did 4. So if I look at my little booklet, it's sometimes nice to see, right? Just to see the numbers. So we have 4, and then we have 5. We have 5, which is 5. And then we have, is that going to work? So we have 5. That's 5. And then we have 6. That's 6. We have 6. And then we have 7. So that's 7. How do I know? We have 5, 6, 7. And then we have 8. 5, 6, 7, 8. And then we have 9, right? 5, 6, 7, 8, 9. And then we have 10. Just like how we write the 10. Okay, this is where I was trying to get at. Just like how we write the 10. We have a 1 here, we have the 10s, and we have the 0. Easy, right? So if we notice, I have my 1s over here. I'm going to make this 0, and I'm going to add the 10. So as we count, we just do 11, 12, 13, 14, and then 15. Again, we have 16. How do I know? 1 and 6, right? 1 and 6 is 16, and then 17, 18, 19, and then 20. 20. When we do 25, right, we could do 35. We could do 45, and then we could do 55. Anybody have any questions? What we're doing is we're just counting on the abacus. We have to understand how to read the abacus before we can go into adding, subtraction, multiplication, and division. So here we do 55, and if I did this, this would be, what number would this be? Anybody know? If this is my 1s, this is my 10s, this is my 100s, put in the chat if you know what this number is. We have these beads touching the beam. And I know sometimes I got lost. Oh, so not a problem. So what's going to happen is we're going to start counting on the abacus. When we count on the abacus, we're going to count here where the dot is. So if you notice there's a dot right here, this is what tells me where the 1s is. Because we have the 1s, just like how we count, we would count 1, 2, 3. Notice that we do is we know that this beads are counted because it's touching the horizontal bar. There we go. It's touching the horizontal bar. When these beads are touching the horizontal bar, we get it is considered counted. So these 3 beads are considered counted. Those are called 3. I'm sorry, that's the number 3. And then we have 4. But notice that we don't have any more beads. We have to figure out where to go 5. To do 5, it will always be the top bead. Always, always, always. So that's like kind of like a... That's just the way it is, right? Just like how we have 2 arms or whatever, right? That's just the way it is for the abacus. So on the abacus, depending on where the bead is, so we have the horizontal bar. This is also considered the beam. So if there's this, on top of it is the top bead. This will always have a value of 5. Hey, Amma. Hi, Jen. Hey, Denton. And, oh, you know what? I'm like missing out all of the, oh, Kamita. And then, wow, there's a lot. Hi. Gamma Gui, it is actually 355 because this is the 5. So when we did 3, 5, 5. So I'm going back to here. We're counting. This is 5. This is 6. Right? How do I know? Because we have the values of 1 and then we have a value of 5. And then we have 6, 7, right? 5, 6, 7. And then we have 8. 5, 6, 7, 8. And then 9. 5, 6, 7, 8, 9. So when we do this, we have 9 and we have 9 and we have 9. But that's different. It depends on the zeros. So this is actually 9. And then this, because it's a 9 and a 0, this is 90. And then this would be 900. Because when we talk about it, we actually use the abacus with place values. So we have 1s, 10s, 100s, thousands, and then 10,000s. Right. Thank you, everybody, for commenting. Yes, thank you. Anybody have any questions before I go on? Because we're just counting on the abacus, and we're going to do, you know what? I have questions for you. I have questions. And so if I did this, and I did this, and I did that, what number is that? Oh, fantastic, Pacemaker. I'm hoping Pacemaker, we go a little, we go at our own pace, right? We keep moving at our own pace, and when we get there, we get there. Oh, which reminds me, anybody know what this number is? Before I continue on. Yeah. Anybody, let me know what this number is. It's a little bit, is it tricky? No, it's not going to be tricky. Yes, let's see. 2,709. Yes, exactly. And there's a comma. So if you notice, there's a comma, and it's exactly how we did it with the dots. So if you notice, there's actually multiple dots. There's the 1s dot, and then there's a 1000s dot. So it's kind of nice to be able to use the dots as a separator. I'm just playing around with my camera, and I'm just wanting to make it look good. That's all I wanted to do. So, and you're exactly right. When we do 2000, we have a comma. So that's why we have the dot here, and that's why we have a dot here. That is also a reason why if I get a bigger abacus, and let me find my bigger abacus because I like big abacuses. Abacuses. This one is 13 columns. This one I have is 7 columns. You could do 13 columns on a colorful one. What's the difference? It just means that there's more digits. So here, if you notice, I actually have more dots. I have 1, 2, 3, 4, 5. I have 5 dots here, whereas this one I only have 2 dots. So why is there a difference? Well, it's just more. It's just more digits. So on a 13 column abacus, I would usually start in the middle. But with the smaller abacus, I would like to start either here. I would like to start here because then I have a bigger number as I grow. So I scroll here randomly, and I'm surprised how easy you make it understand. Woo! Let's go! Thank you so much. But it's, you know what? It's super easy. It's super easy. But it's just one of those things, like, you just take a look at it, it's like, huh, I don't know what's going on. But then when somebody says it, it's actually quite intuitive if you really think about it. And so, okay, so why are the different colors? Well, okay, so I've been teaching abacus for more than 20 years. And I've been dealing with a lot of the single colored. And I was like, you know what? Single colored. This one is 23 columns. So the 23 columns just means more numbers. I don't know how big your numbers are going to get, but they're like huge. But again, because this is 23 columns and my camera is small, I'm going to start in the middle. This would be the middle. And I would reset it and it would be the same thing. And it would be depending on how big your numbers are. I mean, 23 columns is a lot of digits. So I'm going to go back to something that's a little bit more manageable. So again, and then when I found the colorful one, I was like, oh my god, look how cute this is. So I actually picked this up, and I like it because the younger kids, usually my focus is to focus in on the preschool kids. That's why I created this book. The reason why is because in Abacus we don't talk to children that don't know their numbers, Papa. But I wanted to make it more entertaining and more. I wanted to modernize Abacus, and so Abacus, if nobody knows, it's actually a really ancient tool that it goes back way before it's. I think they say it goes it goes right around like the part of the bartering system, right? And what it was, it started off with counting pebbles. So we actually started counting pebbles long time ago, and then they just started making it into a frame, and it just made it easier. There was a 10 beads, and then they made it to a 10 bead, and then after a while it came into a Chinese abacus, and the Chinese abacus there's 5 beads on the bottom and 2 beads on the top. It works kind of the same. We can talk about the comparison. And then after that, you know what Japanese do, and they always do, they make it more efficient. And so that's what we do here. Now, the difference between all of them, like, so this is a 23 column. This one is more of a competition abacus. And yes, there is competition abacus. There is not, I have not ever heard of a competition Chinese abacus, but I have heard of the Japanese abacus competition. You can look it up. Yes. So I have some questions. I'm just started to look up. I'm so involved with like talking about abacus. I sometimes forget that there's questions. Yes, we can demonstrate multiplication and division. Yes, man, should I get one to show my son in kinder? Yes, actually. So your son is in kinder. I would recommend the nice colorful one because they're still in the phase where they like colors. But However, if the color is too overwhelming, and I know it can be, right? Like it's a little much, you could go with this one. And this is the 13 column. You know, there's no harm in any of them. It just depends if sometimes, because somebody was saying that it was too much, it was overstimulation, and I was like, oh, yeah, that could be a thing. Well, I mean, that's a thing. And I was like, oh, I didn't think about that. But, you know, I was thinking about it because I was looking at this, right? And I was looking at this for 20 plus years. So when this came along, I was like, oh, that's kind of nice. It was a novelty. It was a shiny thing. Anyways, so because your child's in kinder, you can start off with doing the counting. So what I would do is you can start relating the two. I mean, we do it already, right? They work with die. There's a die, and then there's these number blocks. Let me move it. Okay, so there's these number blocks that we're using as well in school. I'm not a teacher at a school. I'm a abacus teacher. So some of the things that I know of, I don't know the full strategies, just so you know. So like I focus on, you know, teaching children, people in general, what the abacus is, because I think it's the greatest thing next to sliced bread. So going back, if you have a die, I would relate it. So if I want one, that's what I want, right? If I want two, then I put in two. So the idea was to be able to correlate from here to here. And that's what the book is. And so what I did is I mean, if your child doesn't know their numbers, the reason why I did preschool was because I wanted them to relate the number to the abacus. Oh my god, I gotta play with this stupid camera. Sorry, I don't mean it to be dark, but oh my gosh. Okay, so then I have it where, they were tracing the numbers. So if they're having problems with tracing, writing numbers, because they're only in kindergarten, preschool. Sorry. And then, so the idea was to get them to, engage and be a little bit more interactive and stuff to understand what they're doing. So, I mean, I was just trying to modernize Abacus. Really, I was trying to modernize Abacus because a lot of the Abacus that's out there is just a bunch of numbers and it gets really boring really quick. Okay, so I am easily influenced and highly fixated. You got me on how passionate you are on this topic. Oh my god, think about it though. It's been like 20 plus years and I'm still talking about it as if it was like the thing that I just learned. I make a lot of epiphanies. Like, so what I notice is that abacus, abacus is the gateway to complex math. And why? Because when we work with adding and subtracting, it is really quite interesting on how it relates to algebra. And I need to move my mic. There we go. Never mind. So I mean, what I've done is I've been creating. I just started going down this path to like try to go to the internet, and then I found TikTok, and I'm like, oh my god, TikTok is so cool. I'd be very sad if it leaves. Okay, so going back to here, what I did is I made it where you have the numbers and then you have the beads of the abacus. The reason why I did this is because this is abacus focused. I mean, we actually go into adding and subtracting. So let me go further in. We only deals with numbers from 0 to 9. From 0 to 9, and then from here we talk about counting forward and we talk about counting backwards, and we can do it on the abacus. So to show it, and this is the interesting thing about the abacus, right? So when we count forward, we just adding the one bead, and the idea is to see that we're adding the one bead to the beam. When we add to the beam, we know we're gaining. But then also when we add, we also show the children how to subtract. So it's not a strange thing that they're like, oh my god, what's good? What's subtracting? In abacus, when we add, we show them how to subtract. So it's balanced, like yin and yang. Anyways, so, and I entertain myself a lot. So when I take away, notice I remove the one bead. I remove it from the horizontal bar, so now I have two. So it's easy to count backwards as well. So when we count forwards, we also show how to count backwards. Why? Because when we start going into adding and subtracting, the adding and subtracting, taking away the bead and adding a bead goes hand in hand. And as we go further, we're going to start learning formulas. And as we start learning formulas, we need to know how to utilize the pieces. So I'm going to continue on with my thought process because just to understand like what we're trying to do. So the idea was to know that we can, when we add, we know how to subtract. And we use our fingers because it's like, we use our fingers on the abacus to help us calculate. Hopefully you keep your hand on the abacus, your left hand on the abacus, and keep it still. Because if you don't, then all the beads get messed up and then you don't know what your numbers are. Anyways, so the left hand holds the abacus, the right hand does the calculation. There are some kids that use like two fingers to do that. That's fine. I mean, I'm not a stickler on that. I don't teach competition abacus. My goal is to make math comfortable for kids and everybody alike. So if you're willing to learn how to use the abacus, I am open to teaching. So that's why I'm here. And so when we talk about it, we have our gesture, we have our finger movements, and this is what we do. We do 1, 2, 3, 4. I know this is still the beginning part, right? So I'm just reiterating on how to read it. So we have 54, and then if I add this, and then I have that number, what number do we think this is? If this is our ones, this is our tens, this is our hundreds, and this is our thousands. So as I talked about it, what number do we think this is? I know I also talk coming fast, and I gotta slow down a little bit. All right, so what we're doing is we're trying to figure out what this number is. And let's see. Ooh, we got some good ones. Yes, yes, it is. Exactly. We have 6,754. Great. So we're going to continue on. We're okay, right? We're understanding how to read the abacus. So then the idea here was to understand the relationship of the numbers. We count backwards, we count forwards, we figure out what the numbers are in between. We understand what the numbers are surrounding, right? So we figured that out, and then what it is we're doing the which number is bigger, which number is smaller, and I wanted them to understand how to use the greater than sign and the less than sign. And again, that's what it is. So then we start going into adding and subtracting. So before I start going into multiplication, division, because what is multiplication, division? It just means fast addition, right? So the next steps is to understand how to add, which is super easy, right? Because all we're doing is we're moving the beads. But the difference is in elementary school, I noticed when I was doing research, the focus is the result, right? And actually, we don't, in Abacus, we don't fixate on the result. What we think about is the process. What does that mean? So one of the videos I was looking at, there was like, okay, we're gonna do some addition. I never knew this responsive. I've never been this responsive in any live. I'm so hooked. Okay. So there was a video, and I was like, okay, well, I'm going to watch this video, and it was about adding, right? It was like, 5 plus 3. And they were like, okay, this is 8. And I was like, ah, that's right. So in the video, they're like, this is 8. We know 8. We know 8. And I was like, oh, okay, whatever. But when I look at it on the abacus, right, we're going to add 8. We're going to add 5, and then we add 3. And this is 8. Why am I here? Because I'm going to use this as my dot. This is where my ones is, just because it's easier to see, and then my camera is a little small, right? So then it's like, okay, fine. That's, let's keep going. They actually had like a series of questions, right? And then the next one that they did was like 7 plus 1. 7 plus 1, it's 8. Yeah! And like, the crowd roars. I'm like, okay. So what is 7 plus 1 looks like on the abacus? Well, we have 7, and then we have 1. Okay, that's fine. Not a problem. I got to get some pink and white. I'm sorry, right? I watched like 2 lives, and then I ordered one. Hi, Nat. Welcome. Gotta find some. Oh, you know what? There's a pink one. I don't know if you can, but there is, and I got this from a retired abacus teacher in the neighborhood, and she gave it to us. But I don't know if you can find them anymore. And this one was kind of nice. This is made out of bamboo, and I believe that this is also made out of some sort of bamboo or plastic. I think this is made out of plastic, and this. Can you hear me? Can you hear me? Yes. Great. Okay. So, oh, I just heard my mic just turn off. Okay. There's this other one too, and it's the same thing. She gave this to us, and I don't know. So those are like the different abacus. Okay. So going back to my story. So then it was like, okay, you know what? 7. We did 7, right? We did 7, and then we did plus 1, right? We did the plus 1. But notice that they focus in on the result. So then the next question, their final question that, is 4 plus 4. Well, we know 4 plus 4 because I don't know how old everybody else is, but when I was a kid, we had to memorize what 4 plus 4 was. And it was like, why do we have to memorize? So again, we had to memorize what 4 plus 4 was. And again, they were like, 4 plus 4, everything equals to 8. These are how you work with 8. And I'm like, okay. But now since I know Abacus, I know how to work it. So in Abacus is different. Why? In Abacus, what we do is we focus on what is being added. That is the process. We focus on the process. We do not focus on the result. Just like in life, right? We focus on the journey, not the goal. Anyways, so the idea is to focus on the process. What does that mean? Well, now we got to go to a little bit of a backstory. When I add the 4, right? When we add the 4, I don't have enough beats to add the 4. What's another way to add the 4? In school, we're actually teaching kids Common Core, which is fantastic. I actually, full on agree with it. The reason why is because now we're starting to teach the children how, what is 4 plus 1 is equal to 5. 4 plus 1 is equal to 5, or 1 plus 4 is equal to 5. We are teaching this to children. What does that mean? Every time I color in four boxes, I have 1, right? I have 1 left over. So that's how I make a 5. Oh, that was the thing, is we want to learn how to make a 5. And that's the fantastic thing. But the problem is, in school, that is all we stop. That's all we do. That's it. But now in Abacus, we're going to take it one step further. In Abacus, we're going to isolate the variable. It's not an x, but it's a 4, and we're going to isolate it. Why? Because we want this 4 right here. So we know that there's this thing right here, this addition sentence. They call it addition sentence. And what we're going to do is we're going to do a little bit of algebra, which is isolating the variable. When we isolate the variable, I sound strange only because in Abacus, we don't talk like this. We don't. I had to find these math terminologies to understand why Abacus. Abacus is like the stepchild of math, which is strange because we have all these manipulatives. We have these these boxes, these blocks. We have a die, but nobody ever talked about the abacus. Anyways, that's a little bit of a rant. Now I'm going to go back. So we're going to isolate the variable. When we isolate the variable, so tick 1 down from the top and you get the bottom. Yes, exactly. When we isolate this variable, we're going to move this 1 to here. So I'm going to rewrite my equation. I'm going to rewrite my formula. This is a formula that the kids will memorize. It is plus 4 is equal to plus 5 minus 1. We need to plus the 4 plus the 5. Plus the 4 equals to plus the 5 minus 1. This is something that they're going to need to chant and understand. Not understand, but memorize to the bone, because that is one of the building blocks of abacus. Why? Because if you notice, we have 4, and then we want to plus the 5. We call these operators out loud because it's a gentle reminder we need to add, right? We want to plus the 5 and then take away the 1. That is what I just did right here, and exactly what Dayton. Is it Dayton? Am I saying that right? I hope I'm saying it right. Dayton. And that's exactly what it is. You take the 5 from the top, we add the 5 from the top, and we take away the 1 from the bottom. And notice what we're doing is we are substituting this equation into here, which is another algebraic term. And it was really quite interesting. So let's take it one step further, right? Let's take it to 3 plus 4. Now, again, you could do, well, since we learned our doubles, right? Our doubles plus 1. Oh, no. We're going to do our doubles minus 1. Okay, we can do doubles minus 1. That's fantastic. But instead of learning, you could learn it, not a problem. You could memorize this, not a problem. I'm not going against it. What I am trying to promote is we can do this in the abacus. We can understand the process, right? The process. So if I go here, I'm going to go over here now. So I do 3 and I need to add the 4. Well, I already know how to add the 4. How do I now add the 4? Well, I did it right here, right? All I got to do is take this, substitute it into here. Now I talk like this because I'm talking to adults and we use big words. When I talk to kids, I just say plus the 4 is equal to plus 5 minus 1 is equal to plus 5 minus 1, and that's it. Right? But in here, what I want to do is I want to show how it relates to, how abacus relates to mainstream math. And this is exactly what we're learning. We're teaching the kids this. We just got to take it one step further. So going to here, I already know how to plus the 4. When I add the 4, all I got to do is plus the 5 and take away the 1. And that's it. Right? So now my answer is 7. Oh, Thank you so much for the heart. I know, I watch these too long at night because the next day I catch myself. Exactly, exactly. You start chanting it. You start chanting it. But then the thing is sometimes we have the numbers in our head and we get kind of mixed up a little bit. But when we start vocalizing it, it makes sense, right? But that's why we have to say plus 4 is equal to plus 5 minus 1. And then we go through the whole, there's a whole thing, right? Because what's another way? We know 3 plus 2 is equal to 5. So this is part of making 5. This 2 plus 3 is equal to 5. These right here this is all you need to know. That's it. Well, there's another set of things you need to know. But we're going to continue on. So let's isolate the variable for the 1. So it would be 1 plus the 1 is equal to plus the 5 minus 4, right? And then plus 3 is equal to plus the 5 minus 2. And then this one is plus 2 is equal to plus the 5 minus 3. And that's what I do. That is all I do. All I do is do 5. And this is one of the critical formulas. In Abacus world, we call it formulas. In mainstream, you can call it addition sentences, equation. I think you can call it an equation. You can call it a formula. Well, in Abacus, we call it a formula, and there's some other ways to call it too. And that was the other thing, is trying to understand like all the different terminologies that math does. Okay, so that was why. Okay, so that was a long story to explain why I started with this. So in this book is my preschool book, and I only talk, and not only, but I talk about the plus 1, and what we're trying to do here is to show what I do to add the 1. We don't learn our doubles. We don't do 1 plus 1 is equal to 2. What we do is we show 1 plus 1 is 2. Now, the kids, depending on how old they are, they'll be like, that's easy. I don't care. But the idea is to go through the motions, because as you go through the motions, you'll see how the abacus goes. Now I know why someone asked how you're always live. What? I enjoy talking about abacus, and I enjoy explaining, the simple things. This is simple, right? And it's so easy, but I enjoy it because you know what? I have you guys to talk to. And it's nice and it's refreshing because, when I'm talking to kids, they don't really have a discussion. They're like, I don't get it. You know what I mean? But when I'm talking to adults, they'll be like, oh, so we have different ways to communicate. And I like it because then I'd be like, oh, this is how I talk about it. So here, the same idea, this is like this number, right? We have this number. This number is 7. And so here I wanted to add the 1. And that's all I'm doing. I'm adding the 1. The reason why is because I didn't want this green one to be labeled as 1. I wanted the idea, the concept of this one bead is 1. So we're only moving the one bead, just like we're doing this and we're just doing this. So, wait, I love it. Wait, I love it. Through you, I could tell she's passionate. Oh, you guys are so funny. Okay, so when I did this lesson 9, and so lesson 9 was plus 1, plus 2, plus 3, and plus 4. We only did up to 4 for now, and then afterwards, and then I added like little activities because I thought it was kind of cool. I added activities, so the idea was that they would have to answer the question and they would have to find the answer. So that was some of the things to try to get them to be more engaging. So then afterwards, just as I said before, we have to show the minus. This one is color by number, and it's a big giant owl. And then what they had to do is they had to color in the same abacus. It was, something easy, something simple. So again, we have the 4. After we add the 4, we're going to start taking away. So lesson 10 in this book is taking away minus 1. So we say, it doesn't matter how you say it. Minus 1, subtract 1, it doesn't matter. But the idea is to take away the 1 on the abacus. So when we do it, we go to the 4, right? If I have 4, I'm going to find this one. We'll do 2. We'll have 2, and then we take away the 1. Right? So notice the kids will start seeing that there's that pattern. We take away the 1. Right. So we have the ones, we have the -1, -2, -3, and -4. Cool. So then the next one is to do the 5. Now the reason, this was another thing that kind of blew me away. So the other thing was, you know, like how we round. If you notice anything below the horizontal bar, we round down. And anything above the horizontal bar, so when the 5 is there, then we round up. And I was like, oh, that's cool. And I didn't think about it, but it was just one of those things like, oh, whoever thought about like doing the abacus, like doing the 5s and the 10s, it's just like, it's amazing. It's amazing what happens. So anyways, so we can use the abacus to help us learn how to round up and how to round down, right? When I did it, there was like a person that did mountains. So I was like, oh, that's cool. Anyways, so we have the +5, and then it's the same thing. All we're doing on the adding of the 5 is add the 5 and take away the 5. Add the 5, take away the 5. And it's the same thing with the 6. We add the 6, right? When we add the 6, we want to bring the 2 together. We want to add the 6 like this or add the 6 like this. So if I had 1 plus 6, it's these 2 beads. That's what it is. And then we have 2, and then we do 6. It's these 2 beads. So the questions are very specific. If you choose to go down this path, which is great if you want to, when you choose to go down this path, I would refrain on testing your children on the numbers. Just wait a little bit, because the numbers are very specific. What does that mean? Okay. When we're doing, and I don't know if this is what they're showing in school, but we have an addition table, and I took the time to try to figure out how to make it look a little bit better. So what we did is we did the simple. This is the simple right here. The next thing we did is we did a little bit about how to make a 5. When we make a 5, that's what this pink is right here. When we make a 5, so that's why you have to be careful with the numbers and when you add and subtract. Why? Because you don't want to teach them, you don't want to test them what is 3 plus 3, because they didn't learn that yet. If they're still working on this part here, you can test like 2 plus 2, right? You could test 5 plus 2. But refrain from testing something that the kids don't know just yet. So when I was building my books and building my worksheets, I wanted to make sure that the questions didn't confuse them. There's always going to be an answer to them, because it gets really, some of the kids can get really overwhelmed if they don't understand what they're doing, right? So then after you understand how to do the 5, which is making up the 5, the next step would be making up the 10. Actually, the next step would be minusing the 5. So again, I did the same thing, but now we're in the subtraction table. And with the subtraction table, again, be careful testing them on the numbers until you know where until they're comfortable with all of the formulas. That's what I would refrain from. The reason why is because some of the questions are a little loaded. Oh, one of the other things I came across, like one of the parents was like, well, I want my child, and she just started, like the kid's like 7, and she just wants her kid to know what 8 plus 5 and 5 plus 8. Isn't it the same? No. Why? Because let's do it. 8 plus 5. Now we're going to go into a little bit more of the higher math. Not really higher. It's higher math. But it's a different number pattern. So the question was 8 plus 5 or 5 plus 8. Now, they look like they're the same. They look like they're the inverse, but they're not. Why? Well, let's take a look. So what we're going to do is we're going to do 8, and then we're going to do a plus 5. Now, if you notice, I don't have any more beads to plus the 5. The big question is, if I don't have enough, how do I do it? The biggest thing, I never learned how to add with an abacus. I'm going to watch your videos. Oh, good. I hope you enjoy them. I don't know if I'm as exciting as it is when I'm live. But let me know if you have any questions. So we're back to here. So I add the 8 and I want to add the 5. There's not enough beads to add the 5. So the question is how can I do it? How can I add the 5? There's no way to add the 5. Oh, don't be like that. I was going to call it out, but I wasn't going to do it. In school, we're teaching children how to make a 10. This is where how to make a 10 work. We do 5 plus 5 is equal to 10. Wait a minute, that's a double. No. No. This is a part of the formula, right? This is just a pair. We know what the pairs are. Just like how we know that 6 plus 4 is equal to 10, and 7 plus 3 is equal to 10. This 5 plus 5 just happens to be a thing, right? I'm going to go down the rabbit hole. Yeah, you know what? Going down the rabbit hole is kind of funny, especially when you go to YouTube and you look for Abacus and you'll see all these random people doing this. And I'm like, what are you doing? But I think there are some videos that do explanations, but I know they don't explain it like I explain it. Anyways, so again, this is 5 plus 5. So we're back to 5 plus 5. Now notice what we're going to do again, just like what we did up here, we isolated the variable. When we isolated the variable, do 5 is equal to plus the 10 minus the 5. So what does that mean? Well, and we're going to plus the 10. I'm over here. Where am I? I'm over here. I'm going to clear it. I'm going to start over. So I'm going here. I want to plus the 10 and minus the 5. This plus the 10, there's multiple math terminologies that you can talk about. This can be grouping, regrouping, carrying on, or borrowing, depending on what you were trying to do. So that was another thing that I've noticed is the terminologies, it gets kind of confusing when we try to explain it. The kids are starting to learn a lot of vocabulary in school. And I mean, it's great to expand their vocabulary. But in Abacus, we just say plus 10. What does plus 10 mean? The only thing it means is you go to the next column. That's it. That is it. Hands down, that's it. You go to the next column. That's what plus 10 means. So what I'm going to do is I'm going to go to the next column. I add the 10 because it said plus 10. And then I take away the 5. So then my answer is 13. Okay, that's fine. Now that's fine, right? We're done with that. So isn't it the same when we do it on this side? No. Why? Because now we're going into something different. What does that mean? Well, I'm going to add the 5, and now I'm going to do the 2. Remember, how do we add the 2? How do we add the 8? Is there enough beads to add the 8? No. So how do I do a 10? 8 plus 2 is equal to 10. So when I isolate the variable, right, plus 2 is equal to plus the 10 minus 2. Easy? Everybody understanding? Everybody's good? I just watched those videos also adding with fingers. Yeah. So, okay, good. So what we're going to do is we're going to add the 8. We add the 8 here, and we're going to plus the 10. So we plus the 10, and we take away the 2. Now, we don't have any more beads to take away the 2. Now we're going into the realm of a two-step equation. This two-step equation is a very common thing in adding. Just in general, it gets like crazy. It gets really crazy because it's 2 steps. What does that mean? Well, what's another way to minus the 2? Remember we did this? We did the plus 5. There's the minus 5. So the minus 5 is the opposite of this. So we're looking at minus 2 is equal to, I can't read it, minus 2 is equal to minus the 5 plus the 3. This is the inverse of this. So they kind of go hand in hand. Because they go hand in hand, what do? We can now minus the 2 for this. We can take away the 5 and plus the 3. Oh, that's too many. Yeah, there we are. Right? What did we do? We add the 5, and then we need to plus the 10. I'm sorry, plus the 8. Right? My question is 8. So I add the 5, I add the 8. Plus the 8 is plus the 10 minus the 2. I don't have enough beads to minus the 2, so I will minus the 5 plus the 3. And now my answer is 13. But notice it's a 2-step. Why is it a 2-step? Because it's that minus 2. That minus 2 is what brings us to the second step, which is up here. Right? Make sense? So this is why it's a 2-step, and that's why you have to be careful if you were to test your child, not to you have to be kind of really hesitant on what numbers you're using because every number is different. And that's the thing, right? We don't focus on the result. We focus on the process, and it's the number that we add is what makes the difference. If that makes sense. So, here is the 2-step. So the first question was 8, so I have 8 plus 5. Notice it's colored in yellow, right? So the next question was 5. So I'm at 5. The first digit was 5, but then the second digit, the second add-in was 8. Notice it's not colored. So these are the two-step equations. So when we do 7 plus 7, that's actually a two-step equation. Yeah, that was mind-blowing. I was like, what? That doesn't make sense. But it does. So, but yeah, you have to be careful when the kids are starting off. You have to be careful because I don't want to focus on speed. What I want to focus on is how do you do it? How do you get there? Is there enough? What do you do? How do you if you don't have enough, so there's another way. So the idea was to critically think of all the ways you can add and subtract, if that makes sense. So we can continue on, but somebody wants to know multiplication. Okay, so let's do multiplication. Are we ready for multiplication? I don't know if the person's still here for multiplication, but yes, you could do addition, subtraction, multiplication on the abacus. We will do simple addition, multiplication, and abacus. Okay, so the next thing we're going to do is we're going to do multiplication. Now, abacus, actually, we don't memorize our 12 times table. I'm just saying. We only go up to 9 because after 9, it gets redundant. Why? Because it just gets redundant. Like what's so here, let's start off with 12 times 6. That's an easy one, right? So we've memorized this. When I was a kid, we had to memorize it. Okay, whatever. So, but now on the abacus, let's work it out. In regular school, yeah. On the regular school, we do it this way, right? 12 times 6. And in school, we start off with our 1s, and then we go to our 10s. That's what we do, right? Now in abacus, because I'm going to abacify everything. Anyways, so what we're going to do is we're going to figure out where we are going to put our answer. So that, oh, this is not an earthquake. It was just me touching my camera. Okay. What we're going to do is we're going to figure out where we're going to put the answer. Why? Because we need to, when we're working with our numbers, we want to start from the hundreds, the bigger number. Let me work it out so you can see what I mean. So what we do first is we understand where our starting point is. To find out our starting point, we need to know how many digits are in the question. So in the question, I have 1, 2, 3. So I have 3 in the question. I have 3 digits in the question. So that means I'm going to start at the hundreds. 1, 2, 3. This is my hundreds. Does that make sense? We're okay right now? So what we're doing is we're trying to figure out where our starting point. So after we figure out our starting point, how we do it, we're going to be doing this thing called distributive property. Distributive property is a term in algebra to be able to go from one number to the next number, right? Do we say that in abacus? No, we just multiply it out. But in the mainstream, how does it relate? How does abacus relate? It's the beginning, the introduction to algebra, right? It's an introduction to more complex math. So what we're going to do is distributive property. We're going to take the 6 and times it by 1. And then again, take the 6 and times it by 2. That's what we're going to do. Now, when we do it, we'll figure it out. So we have 6 times 1 is equal to 6. Notice 6 is a single digit. So what are we going to do? Well, if we change this to a double digit, I have a leading 0. To have a leading 0, I'm going to be a 0 here. I'm sorry. Yeah, I'm going to be a 0 here, and I'm going to move my finger to here, which is the tens, and I'm going to add my 6. Okay? We're okay right now? So now, the next one we're going to do is 6 times 2, or 2 times 6. It doesn't matter. 6 times 2, 2 times 6. We're going to do 2 times 6. It's 12. So what we're going to do is we're going to add the 1 and the 2, because when we talk, it's 12. 1 and then 2. So my answer is 72. Does that make sense? So in Abacus, we don't memorize our anything higher than 9 because it's just redundant after that. We could do it the mainstream way, but it's a little backwards. So let's start here. When we do it in the mainstream way, we start with the ones first. So what is it? It's 6 times 2 is equal to 12. Well, my finger is here. So that means I got to go forward to go backwards. I got to go to the ones. I got to go to the tens and add my 1. And I got to go to 12, which is fine. Now I got to do, so I go 6 times 1. 6 times 1 is 6. But then my finger is here. So that means I got to remember to go forward to add my 6. So it's a little bit, oh yeah, always complainer. Yeah, that it is easy. I mean, when you really break it down, it's actually really easy. But it's backwards when I do it this way, because you got to go forward to go back, and then you got to remember it's okay if the digits are small, right? But when the digits get bigger, let's say we do 1,000. Let's do 1,340 times that by 6. When we get to a bigger number, 63. When we get a bigger number, it gets confusing to go backwards and forwards. So we can work this out. We'll work it out. Not a problem. Let's. How many digits do we have? 1, 2, 3, 4, 5, 6. We have 6. 1, 2, 3, 4, 5. No, we can't do that one. Let's do this one. All right. We are on the bigger abacus. So that's why if you're looking to do multiplication on the abacus, I would recommend to get the 13 column one. Or you could start off with this one, the small one for the young kids, and then graduate them, because they always like to graduate to the next level. So when you graduate to the next level, you can give them a 13 one. Anyways, so if we start, let's do this one. So we have, how many digits we have, right? We have 6 digits. So we have 1, 2, 3, 4, 5, 6. So that's where we're going to start. We're going to start at the, I don't know what number that is. 1, 2, 3, 4, 5, 6. So we're at the thousands, 10,000, 100,000s. We're going to, oh, that's not it. We're going to start at the 100,000s. So now what we're going to do is we're going to do distributive property. That's not the color I want. I want a different color. Let's do green, because I like green. So the reason why I put my finger here so I don't get lost, because you can get lost really quickly with all of the adding and subtracting on with the multiplication. So what we're going to do, we're going to start from here, 6 times 1. So 6 times 1 is equal to 6. 6 is a single digit. I go back 1 column and I add 6. We're all right? Let me know if you start getting a little lost. But I'm going to try to go step by step. So the next thing is 6 times 2. So notice I go 1 and then I go to another. So I go 6 times 2. 6 times 2 is equal to 12. So all I got to do is add my 1, and I go to the next column and I add my 2. So now I'm here at the thousands, which is fine, right? So then the next one is 6 times 3. 6 times 3 is 18. So I add 1, and then I add my 8. I'm still okay. Are we okay still? We're all right? So now the next one is 6 times 4. 6 times 4 is 24. All right? Yeah. 6 times 4 is 24. So I add 2, and then I add 4. Notice I don't have enough beats to add 2. The question is, how do I add? How can I add a 2? So because I'm already using the 5, I can't use the 5. I can't use making the 5 because I'm already using it. So the next one I do, so now this is the side note, I want to add 24. I have to remember I'm adding 24. I'm adding this 2. I want to add the 2 and then the 4. Add the 2. We know how to make a 10. Plus the 10 minus 8. So I plus the 10. Remember what plus 10 means. Just means that if my finger is here, plusing the 10 is just the next column over. So plusing the 10 is the next column to the left, right? Plus the 10. So it's plus the 10. I'm adding the 10, and I take away the 8. Okay? Slowing it down. So then I need to add my 4. That's what this is. I'm adding my 4. And that's it. We're done with the 6. I'm going to cross it out because I don't need to look at it anymore. All right. Now we reassess where our starting point is. We have 1, 2, 3, 4, 5. Okay, we're going to count it. 1, 2, 3, 4, 5. So now I'm going to start at the 10,000 column. Why? Because this is how many digits we have. So we're going to start. 3 times 1 is equal to 3. 3 is a single digit, so I go back one column. I go this way. Do I have any beads? No. How can I do it? Remember our 5 formula. So now we're really stacking in all of the formulas that we learned before. So what is adding 3? 3 plus 3 is equal to plus 5 minus 2. So what I want to do is plus the 5 and I take away the 2. Just like that. So I'm done with this. I'm done with 3 times 1. My next one is 3 times 2. I did not move my finger yet. But now I have 3 times 2 is equal to 6. 6 is a single digit. I go back one column and I add 6. Okay? So now, where am I at? I'm at 3 times 3. 3 times 3 is 9. 3 times 3 is 9. Let me move myself up. Okay, 3 times 3 is 9. 9 is a single digit. I go back one column and I want to add 9 here. Okay, I want to add 9 here. So do I have enough beads? No. What do I do? How do I do it? Plus 9 is equal to plus the 10 minus 1. Plus 9 is equal to plus the 10 minus 1. Again, plus the 10 is the column over. So I plus the 10 and I take away the 1. Now my final one is 3 times 4. 3 times 4 is 12. Do I have enough? Yeah. I add the 1 and I add the 2. And that's my answer. What's my answer? That's a big answer. Okay, so there's the pop question. What is my answer? Let's learn how to read it. We're talking about this number right here. So this is my 1s, my 10s. Let me see if I can make it closer. Yeah, there we go. I have my 1s, my 10s, my 100s, 1000s, and 10,000. What number is this? Yes, 77,742. Yeah. And so that's what it is. We're moving all the beads in order to figure it out. We still need to know our multiplication fact, and we really solidify it, right? And so, but again, we don't need to remember, because how do you do 6 times 12? That doesn't make sense, right? So you only need to learn up to 9 times table. Whew. Thank you so much for the flowers and the hearts. Thank you so much. Sometimes I get so involved with like explaining that I forget to look up and I see questions. I'm like, whoa, there's questions. So that's about multiplication. That's how you add. That's how you multiply. And it's easy, right? You could do the same thing with division. With decimals. And then it's the same concept. We don't really worry about the decimals. What we worry about is the whole numbers, and then we add the decimals later. We could do it, but it's just another thing. It get a little bit confusing because that's what decimals do. Decimals are confusing. And then we also do division as well. But I mean, we can talk about adding and subtracting if you like, but I've been on for about an hour already. I don't know if the person that wanted to know multiplication, if they're still here, but we can go back to adding and subtracting if we're comfortable with that. It is up to you guys where we want to go, or we can do division. We can talk about the books. So I mean, this book, the multiplication book, hasn't been done yet. I haven't made my multiplication book, but what I have done was doing the making the 5 and making the 10. So what I'm starting to do is making sure that I have the activities for the children in my classes, and I have like an online class that is I have pre-recorded classes. And every video is a worksheet. So then, I explain how to use the worksheet, but I also explain how to use the abacus with the worksheet. This one here, okay, so this one here, we talk about adding. We talk about making the 5. I missed the I missed the multiplication one. Will you explain it another day again? Yeah, I'll explain it all the time. I could do it right now. We could do it right now. If we're okay, we can do it right now. I can get my thing. So we can do the owls are cute. Oh yeah, thank you. The owls are very cute. Okay, let me talk about this first, and then we'll do multiplication again. So here we have the +5. The +5, I did it with a story. The story was to do cats in a tree. The reason I said cats in a tree was because sometimes they noticed that the children didn't understand that we actually go to the 5. I'm going to go back to my colorful one. So let me just finish this thought process on this, and then we can go to the multiplication again. So here we have the reason why I said 5 cats in a tree, because sometimes the kids don't understand that we're going to be taking away the tree, the cats, or the 5 and the 4. So remember we were talking about the +4 is equal +4 is equal to +5 minus 1. So the idea here was we want to add 2, and then we want to add 4. There's not enough beads to add the 4, so we're going to go to the cats in the tree, which is going to be my hand, and then this will also be the top bead, and then we grab 4 cats, and you notice 1 cat runs away. So when the 1 cat runs away, we have 6. And that's how I'd explain it. Yeah. So it'd be the same thing with here for the 3. So the idea is if I'm looking for, if I have the 3, right? If I have the 3, do I have enough beads to add the 4? No, I don't have enough beads to add the 4. So what do? I go to the cats in the tree, which is my hand, right? Go to the cats in the tree. That's where the top 5 bead is. You grab 4 cats, and 1 cat runs away. So then my answer is 5. And that's it. So then, if we're okay, I can go back to multiplication. If everybody's okay with that, I can go back to multiplication. No problem. No problem. All right, multiplication. So multiplication, I don't know where you left off at, but what I did was saying that in Abacus, we actually don't memorize our 12 times table. And we could do another one. Let's do, I don't know, let's do 13 this time. We do 13. Okay, we'll do 13. We'll do 7 times 13. 13 times 7. Easy. Easy. So what we're going to do is we're going to figure out our starting point. When we figure out our starting point, we just need to count the amount of digits. And why do we want to do that? We want to do it because we want to know where are we going to put our answer. That's the only reason why we're counting our digits. We're counting our digits 1, 2, 3. So we know we're going to have 3 digits of some sort, right? So that's where we know we're going to be landing on the hundreds. 1, 2, 3. Ones, tens, hundreds. So we're going to start here at the hundreds. Now what are we going to do? When we do distributive property, we're going to times 7 by 1 and then 7 to 3. That's the idea of distributive property. We're going to just count it out, right? Times it out. So the first thing we're going to do is 7 times 1 is equal to 7. 7 is a single digit, so you go back 1 column. So I'm going to take my finger, I'm going to go back 1 column, and I add 7. And then I do 7 times 3. 7 times 3 is 21. 21. So I add 2, and then I add the 1. And then my answer is... And my answer? Anybody know my answer? Sometimes it's better if it's closer, but my eyes are old. A poot. Yes, there you go. It was a little typo. Yes, exactly, because it's 91. Because this is my ones, my tens, and my hundreds. Yes, yeah, a mistype. And then when we count it, right, we count it 5, 6, 7, 8, 9. We know that this is 9, and then this is 1. And then we know that these beads are counted because it's touching the horizontal bar. So that's a little bit about multiplication. Did you want more about Aput? Did you want more multiplication? Because we can go into more digits. And then you know what? We can talk about how in mainstream math, we do it this way. That did not look good. 13 times that by 7. So in mainstream math, I say mainstream because that's what they're teaching in school, right? So in school, they're teaching us how to do it this way. The first thing we do is we're going to do the ones first, and we're going to do the tens. That's how they do it. So I'm going to clear my abacus, and we're going to do it that way. But you'll notice it's a little bit backwards. So here we're going to have 21. Notice we say 7 times 2 is 21. We don't say 2 and a 1, because what we're going to do is we're going to start from here. But no, we're actually going to add the 21. So we got to go forward to go backwards. Does that make sense? So we have 20, and then we have 1. And then our next one would be 7 times 1. 7 times 1 is 7. But again, my finger landed on the ones column. We have to remember to go back to the tens column and add the 7. So I add my 7 like that. So that's why it's a little confusing. It's okay because it's only 3 digits, but it gets more complicated when there's more digits, right? So that was the other example. So I had 348 times that by 8, right? It gets more complicated when the numbers get bigger. That's why I don't recommend the mainstream math. So let's work out this one. What would be my starting point? I had no idea how to start with multiplying on the abacus, so I appreciate this so much. Oh yeah, no problem, no problem. So tell me, how many digits do I have in this question? This is my question. I'm going to clear my abacus. How many digits do I have? 4, exactly, right? Easy, because 1, 2, 3, 4, right? So we're going to do 1, 2, 3, 4. I'm going to start at the thousands. Hopefully you can see that. I'm going to start at the thousands. The first thing I'm going to do is I'm going to do 8 times 3. 8 times 3. 8 times 3 is what? 24? 21, 22, 23, 24. Yeah, 24, right? So I add my 2, and then I add my 4. So I have 24, right? See, notice where my finger is, then I'm just going to add it. Whereas the other way, I had to like go back and forth. So then my next one is 8 times 4. 8 times 4, 8 times 4 is 32, right? So I add my 3, I add my 2, I add my 3. Do I have enough to plus the 3? No, I don't have enough b to plus the 3. So what do I do? What do I do? Well, can I add the 5? Well, yes, I can. So what is it? Plus 3 is equal to plus 5 minus 2. So I add the 5 and I take away the 2. And then I added my 3. Now I got to go to the next column and I add the 2. So I add the 2. Now what do? I do 8 times 8. 8 times 8 is 64. 8 times 8 is 64. So what do? I add the 6 and then I add the 4. And that's my answer. That's it. That's it. Bada bing, bada boom, bada bling. That's it. That's all I got to do. Multiplication is easy. There's not that many rules for multiplication. It gets a little hairy when we start doing division. Division, there's a little bit more rules, and depending on how the numbers are, because sometimes when the numbers get bigger, there's a bunch of rules that we have to understand. But it gets really complicated. Division can get really complicated really quick if you don't keep track. Multiplication is not so bad. So let's do 2 of them, right? So what does that mean? Let's do these three, and then we'll add one more digit. So the problem is 3 times 348 times that by 82. Always complainer. It's 2,784. Yes, exactly. You're right. You're absolutely right. I didn't even think about writing it out. 2,784. Absolutely right. But yeah, so we can do the next one. Let's do this one, but we're going to add one more we're going to add one more digit. Right? Because now it starts to get complicated. So, I mean, when we start adding, then, I mean, this is kind of easy, right? Doing it that way. But it really gets complicated really quick when we start adding more numbers. I'm going to change to a different color. So it's the same thing. I'm going to do this one right here. What will be my starting point? So I'm going to clear my abacus. And I'm going to say, what is my starting point? This is the question. What's my starting point? We're just going to add one extra bead because I don't want to have to, because it gets complicated, right? So we're going to do one more, but we're going to do one more number. So what is my starting point here? We're looking for my starting point for this question. So again, so it's 5. Let's see. It's 5. 1, 2, 3, 4, 5. Yes. 1, 2, 3, 4, 5. 10,000. Yes, it is. You're absolutely right. So when we do it, again, we're going to do the same thing. 8 times 3, 8 times 4, and 8 times 8. Same thing, right? We did it already. So we did 8 times 3 is 24. So we add our 2 and then we add our 4. And then 8 times 4 is equal to 32. 32 not enough. I'm going to add the 5 minus the 2. And then I'm going to add the 2. Right? 8 times 8 is 64. Okay. We're done. Right? We're okay. We're finished with this 8. I'm going to cross it out. Now, what do we do? At the left. Yeah. So what we're going to do is we're going to figure out, we have to find out our new starting point because we've already done with this 8. I'm going to cross it out. So if we're already done with that, what we have to find is our new starting point. So it's 4. 1, 2, 3, 4. 1, 2, 3, 4. So now I'm going to do it again. But now I could do it with a 2. So 2 times 3 is equal to 6. 6 is a single digit, so I go back one column and I add 6. Is there enough? No. Plus 6 is equal to plus the 10 minus 4. So I need to plus the 10. I need to plus the 10. And I take away the 4. Is there enough to take away 4? No. So what do? Minus 4 is equal to minus 5 plus 1. Minus the 5 plus the 1. I'm still here. I didn't move. I'm still here. So our next number is 2 times 4 is equal to 8. 8 is a single digit, so I go back one column and I add 8. Is there enough to add 8? No. What do? Plus 8 is equal to plus the 10 minus 2. So I plus the 10. I don't have enough beads to plus the 10. And this is another two-step. I don't have enough bead to plus the 10 here. Right? I'm going to keep my finger here just for demonstration. So I don't have enough beads to plus the 10. What do? Plus 10 is the same thing as plus 1 is equal to plus the 5 minus 4. Again, this is a making 5 formula. Nothing different. Still the same, just a different, where are we going to fit it in? So plus the 5 minus the 4. Now the next one was minus 2. So I take away 2. No problem. So what's the next number? We did 4. Now we got to do 8. 2 times 8 is equal to 16. So I add 1 and I add 6. And there's my answer. What do you think that answer is? That's a big answer. I would have to really work it out. So does that make sense? So I mean, when we're doing it, you got to take it slow. It's 2, 8, 5, 3, 6. Yes, exactly. Yes, daytime. Yep. Aput. Good job. Good job. So does the multiplication make sense? I mean, it's easy, and the abacus makes it keeps track of things. Any questions? When we add double digits, do we line it up left to right or up and down? Aha! Aha! Okay, so double digits is interesting. What I notice is in abacus, we actually don't need to line it up. It's just pretty. The reason why is because when we do it, we actually do whole numbers. What does that mean? Well, let me give you an example. We'll do this one. All right. Let's see if this one has any special formulas that we need to work on. So we do 64 plus 57 plus 27. Now in school, right, we usually do the ones, right? We do the ones and then we do the tens. In abacus, what we actually do, oh, you're welcome, Aput. You're welcome. Let me know if you have any more questions. If you have any specific questions, we could do it too. Those are just questions I just thought about in the top of my head. So going back to Nat's question, notice though, in Abacus, we actually do it as a whole number like this. So when we do it, I'm going to do 64. So I add 60 and then I add the 4. Now I'm using my Abacus to help me line up my numbers because sometimes it gets like super long. So now I'm ready. Am I done with 64? Yeah. So what I'm going to do, I'm going to move my Abacus down to only show the next number. Why? Because now I'm not going to get confused. So what I'm going to do is I'm going to add the 57. So I add the 5 and I add the 7. Notice I do it as the number as a whole. I want to add the 5, I want to add the 7. Plus the 5, right? Plus 5 is equal to plus the 10 minus 5. So I'm going to plus the 10, take away the 5. Notice, right, I plus the 10. I'm here. I'm adding the 5 here. Notice all I did was go to the next column over. What do we call that? We call that carrying over, right? In mainstream math, we call it carrying over. But in Abacus, we just say plus the 10. That just means we go to the next column over. So we plus the 10 and minus the 5. That's all we do. That is like hands down. And it's such a simple concept. So now we want to plus the 7. The question is there enough? No. What do? Plus 7 is equal to plus the 10 minus 3. So I plus the 10 and I take away the 3. Now I'm done with that number. I'm going to go to the next number. And my next number is 27. So I go 27. I add 2. There's enough. So I add my 2. And then I go here. There's enough for 7. So I add my 7. So that's how I would do multiple numbers and multiple digits. And it works the same way when we do 3 digits and 4 digits. You go one line at a time. And then it's a running total. And it's easier to do running totals than doing one column by one column. Because sometimes when the numbers get to be like 10 lines long and the kids like do their question and they're like, the answers are not correct. So then what happens is, what I would do is I would get them to do a running total. So if we did this question again, it'd be 64 and then plus 57. I plus the 5, right? And then I plus the 7. So then here I would write 121 to keep the total running, because sometimes let me double check that. So sometimes the kids don't do the adding correctly, so I'll do a running total. They will have to do it. And then from here we add 20 and then we add 7. 148. Yes, exactly, always completer. So then we would add our answer, 184. You could line it up, but it's not necessary to answer your question. But as the numbers get longer, I would keep a running total. Just so then if they do make a mistake, we can always backtrack it, because it gets really difficult and disheartening if they have to start all over again. So those kids that, I would just do it in general. I did it with my kids, and it was so helpful, because then they would be able to, it would be like an instant feedback of understanding where they messed up, if that makes sense. So, all right. Anybody have any more questions? Oh, you're welcome. You're welcome. Yeah, I'm hoping that somehow this would get introduced into mainstream math, but that's just a hope right now. But yeah, I mean, it all just depends on how we're working it, but I would do it by whole numbers. And then again, I would use my Abacus to line it up. Are you on the West Coast? Yes, I am. It is 11 p.m. right now for me. And it's going to get cooler, but not like cold like New York. It's only going to be like maybe 70. Right now, today was hot. Today was like 80, 85 degrees or whatever. But yeah, I'm in California right now. Oh, thank you for the rose. Thank you for the rose. I grew up with the Abacus in my house, but never learned how to use it. Did you? Oh, here's a question, Pixie. Did you have the Chinese Abacus or did you have the Japanese Abacus? Because, you know, they're different, but they're not different. So we have the Chinese one. So what I'm looking at right now is the Japanese one. This one, me too, I like Yuri Hermosa. Hey, that's really close. Yeah, you know, I actually have a school. My school is an abacus school. We are out in Monterey Park. I'm in San Gabriel. So, Pixie, did you have a Chinese abacus? It was Chinese. Okay. So yeah, there's the difference. The difference is, and we'll talk about it. Let's talk about the abacus because I like talking about abacuses, and it's kind of cool because you know when we do it, the lower beads all have a value of 1. All the beads of the bottom, this is the beam, this is the horizontal beam. This horizontal bar is what tells us what's being counted. So even on the Japanese abacus, because what does Japanese do? They make everything efficient. How does a Japanese make it efficient? Well, if we look at the Chinese one, we're gonna start adding. On the Japanese one, I'm going to use this dot that's over here. This will be where my ones is. Why? Because it's just easier to get everything labeled. Whereas on the Chinese abacus, nothing's really labeled. So, but I'm just going to start from here just to understand what's going on. So when I add 1, I'm going to add 1. So when I start counting, this is 2, this is 2. This is 3, this is 3. This is 4, this is 4. Now, notice on the Japanese abacus, I don't have a 5. On the Japanese abacus, this is 5. So when I see it, this will always be 5. We have this number. This is 5. 1, 2, 3, 4, 5. Not a problem. Not a problem. I would love to learn the Chinese one too. You know, you can learn the Chinese one, but it's a little redundant. And I'll show you how it is right now. This is how my next step is redundant. So if you look, this is 5. Or this is 5. So now your brain needs to know 2 ways what 5 looks like. If you end off 5, then that's fine. But then if you need to carry on to 6, you actually have an extra step that you need to do, which is this. So in the Japanese abacus, this is 6. In the Chinese abacus, this is 6. They're the same, but there was 1 extra bead, right? There's the 1 extra bead. You had the 5 here or you had the 5 here. So now we're at 6, right? We have 7, we have 8, we have 9, and then we have 10. Now it gets a little bit confusing. It's not logical anymore because on the Japanese abacus, this is 10. This will always be 10. The number next to this column where the ones is, that will be 10. That's even how we write it. We even write it like that in regular math, right? We just write it 10. We have the tens and the ones. Now the difference here is this is 10 on the Chinese abacus. That's fine. This is so interesting. I'm so glad I found you. Oh yeah. I'm happy you found me too. So here, this is the Chinese abacus. This is 10. Now it gets confusing. Why? Because this is not this doesn't look like this where we have a 1 and a 0, right? When we write it, we don't just put 1 here. We actually have one column is a 0 and the next column is the tens. Now, let me put a little spin on it. This is also 10. How do I know? 5 plus 5 is 10. Does it make sense? No, it doesn't make sense. But that's what they did. But there is another way to do 10. So now there's 3 ways on a Chinese abacus to show me what 10 is. And when you start to have too many numbers to make the same, then it gets a little confusing, right? Your brain is going to have to know that this is 10, or this is 10, or this is 10. So I think I see why that there's no Chinese abacus competition. There is mostly the Japanese abacus competition. And they talk about speed and the quickness. Like there's a girl on YouTube that is like the human calculator. She learned the Japanese abacus. And she competed against Bill Gates, and Bill Gates had a calculator in his hand. And she was able to do it. And it was great. Do I know how to do it? Not in my head. Give me an abacus, I might be able to show you. But I didn't grow up with the abacus. I learned the abacus when I was old. It was when my dad decided to go to into a business trip, and one of the moms, her child was autistic, and she's like, "This is the greatest thing. My son is so good at math and stuff. Have your children and learn it, abacus." And he's like, "Oh wow, that's really cool. I'm gonna have my grandkids learn, but first I'm gonna have my kids learn." And so he, as Asians, I'm Chinese, so as Chinese parents do, they force whatever force whatever on us. And so it was me and my brother learned how to do the abacus. Am I fast? No, I'm not fast. Do I know how to explain it? I know how to explain it. But my kids learned how to do the abacus. And so, oh, you got to go. Yeah. Can you show the large numbers adding on the abacus? Yeah, I could do that too. Got to go. I got to learn. Oh yeah, thank you so much. I got your learning guide in the 13 columns. Yeah, okay, great. That's great. Always complainer, but you're always complaining. I'm kidding. So great. Thank you so much. My mother was very into math. She is a certified yeah, and she has her own firm. Yeah. We can do it, a poot. But it doesn't make, I mean, okay. I mean, it's okay. So yeah, so my kids know how to do it. I put my kids through it, and we had a whole curriculum on how to do it and stuff. And it was just one of those things like I wanted them to learn. And when they were doing, when they started to do Common Core in school, they didn't get confused because Common Core, Abacus really aligned with whatever the Common Core was doing. It was really quite easy and interesting, because in Common Core we started talking about how to make a 5, how to make a 10, and in Abacus you already do that. That's part of the system. So on the Chinese Abacus with one of these, let's say, right? So we do 60, we do 4. All right. Have I ever done it? You know what, Aput? I'm telling you right now, I've never done adding and subtracting on the Abacus, on the Chinese Abacus. So here, I want to add the 5. I want to add the 5. I can add the 5. Oh my god, this got complicated really quick. Okay, so I'm going to add the 57. I'm adding 57. I just added the 5. You could do that. And then I add the 7. Can I add 7? Well, I have 5 and I have 10. So if I have 10, I take away 3. Now I have 27. I add 2 and then I add 7. Is there enough to add 7? No. So I do the 10 and then take away 3. How do I take away 3? How do I take away 3? Take away 3 is minus the 5 plus the 2. Okay. So now we have 148. My brain says that the abacus would be easier, but I'm autistic and it might be why. Oh, I gotta head out. Oh, I gave you a follow. Oh, thanks for the follow, Pixie. Oh, who you like the Chinese? You like the Chinese abacus? I guess. I mean, it seems kind of confusing because this right here, this 10, it baffles me because it's not part of the column. So this one should have been like this. You know what I mean? I'm complicated. You're funny. So I mean, I see it. It's just it would take me it takes me a little bit longer to really recognize, because like what it is it takes a while for me to recognize that this is 10 and this is 10, and then because this is 10, that means it'd be on the hundreds. Yeah. I could see how this is not a good competition adding. It's not a really good competition adding. Because it's not quick, because your brain has to do some your brain has to think more when we're making this as a hundreds. So I could see it, but yeah, there's a lot more thinking in the Chinese abacus to figure out if there's another way to do it. I could see that. So yeah, it was good. That was a good exercise, but woo, that was a tough one for me. I had to really think about that one. Because because I've been working with the Chinese abacus, the Japanese abacus, it's a lot easier for me to do. But, yeah. Oh, anybody have any questions? I've been on for about an hour and a half. Hey, Worry Warrior. Thanks for demonstrating. No, not a problem. I'm happy to help. I'm happy to explain it. I mean, if you have any more questions, I'm here. I'll be on live and more live. But I do enjoy talking about the abacus, and it's funny, like, just how easy the abacus makes everything. It's just so crazy. It's crazy how everything is so easy with the abacus. You know your 5s, you know your 10s, then you have everything to do for adding and subtraction, actually. So, yeah. All right. Well, it's about an hour and a half. If there's any other question, I wish I was taught in American school. I wish it was taught in, funny, it was taught one time in 1975 in Montebello, and somebody came by and taught the teachers, and the teachers did it. Do they do it now? No. Nobody carried on the tradition of teaching abacus, and it is too bad. It is too bad because we have all these other manipulatives that we're introducing to the children, but nobody is introducing the abacus. And it's just an interesting thought. Like, they introduce the die, but they don't introduce the abacus. They see it there, but they think it's a toy. It could be a car, but or it could be a massager. Yeah. Yeah, that's what I noticed, and it's a little bit disheartening to see that, they'll introduce everything else under the sun, but they won't introduce the abacus. Woo! I gotta tell myself that I'm not a robot. Let me see. Where is my picture? And there I go. Good. So, yeah, that's the goal. It's a goal to try to introduce it and make it more well known. Because a lot of people don't even know what an abacus, even how to say the word. So I'm just here to spread the word that abacus is the greatest thing next to sliced bread. I crack myself up sometimes, but yeah. So that's the thing. I mean, that's what I'm trying to do. I'm trying to educate and also bring out more worksheets and modernize abacus. Here's an example of an abacus book that is out there. This is not mine. This is one of the ones that are out there. This is what my kids had to work with. And if you notice, it's 60 questions on one page. And it's a small book, but it gets kind of monotonous. Like, it gets boring after a while. Like, after 10 questions, I want to fall asleep, because it gets kind of mind numbing. So, but yeah, I with my worksheets and my workbooks, and just I like creating the worksheets, but I'm hoping that it will catch on, and we'll see. I agree. Thank you for your hard work. Yeah. No, I appreciate it. I appreciate the questions. I appreciate the conversations, because we don't get conversations about, our passion. So this is one of the things I really enjoy talking about. My kids are tired of me talking about abacus, and so is the husband. So they were like, go find somebody else to talk about abacus. But I do hope it does pick up. I just, it's just one of those things, like, yeah, learning abacus, there's a lot of things that very similar to algebra. And so if I can show that it's really closely related to algebra, learning algebra would be really easy. So that's what I noticed with my kids, is like, when they started learning algebra, they're like, how do I know this, but I don't know this because I was never taught this. And then when I started explaining, like, we actually do a lot of the stuff that you're doing in algebra, we're doing it in abacus. It looks just a little bit different, like isolating the variable, or substitution, or distributive property. Like, we do all these things in abacus, like as part of the method, but we don't label it. And so that was the one thing, is I think the gap that I'm trying to fill now is that there is a relationship between what we do in abacus and then what we do in algebra. Yeah. So then, I mean, I can really philosophize about it too, because I just really think it's interesting to be able to correlate all of the math terminologies into the abacus world. And it's one of those things, like, there's a lot of epiphanies that I talk about, because, like, here we say plus 10. Plus 10 is actually, if you really think about it, it's like carrying on. And if you do the minus, it's the borrowing. And so again, those are math terminologies that we don't use in abacus. And I think that I needed to do that extra step to be able to relate. Oh yeah, we are doing a carrying over, or we are doing a borrowing, but we don't call it that, which is interesting. So, yeah. I wish it was taught in American schools too. So, if you have any other questions, anybody else? I mean, I see 10 people still. I don't know if 10 people are still really here. I don't know if the count is real, like if it's real. This is awesome. Hey, Caleb. I feel like I need to learn finger abacus. Okay. I actually don't know finger abacus. Oh, thank you so much for the, yeah. I actually don't know finger abacus. I've seen it on YouTube. Can you do division with decimals? Yes, you can. Ethan, it would still follow the same lines as as the mainstream, right? So if we had, let me get a question. I don't have any more questions right now. I'm following you and I'll ask if I have any. Okay, great. Yeah, let me know when you have any more, and I'm always live. So let me know whenever I'm on and then we'll talk about it. Let me find a decimal question. So let's do this. You know what? Let's do something easy. So we have 0.7272, right? So we can do this. What does that mean? So here's my decimal. In regular math, we need to do is we need to take the decimal and we need to move it over. That's kind of a given. So we got to move it over here, right? So we have to rearrange this, and then you're done with the decimal. So now we're just doing division. That's really it, Ethan. Even if we did it this way, like 721. If we did it this way, it's still the same. So then what we do is we figure out what our starting point is. We have one divisor and one dividend. It'd be 1 and 1 is equal to 0. So we would start over here, right? This is where our answer is. But we're going to put our dividends here. So we do 7 and we do 2. I don't think it's going to work out, but that'll be fine. So then the question would be, what times 7 is equal to 7 or less? 7 times 1, so I'm going to put my answer here. 7 times 1 is equal to 7, so I take away 7. And then we have to reassess who is bigger, the divisor or the dividend. The divisor is bigger, so then what I'm going to do is I'm going to put my finger here, and the question is, what times 7 is equal to 20 or less? And the answer is 2, right? 2, and I take away 14, but I don't have any more beads to take away 14. So it's the same way. It's just, having the decimals, it's kind of the same way. It doesn't hurt. It just happens to be wherever. I mean, it's the same idea if it was 0.0007 by 72. You still need to divide. You still need to move the decimal out, and then when you move it out, then you figure out what your answer would be. Does that make sense, Ethan? But yeah, you could do division with the decimals on the abacus. You could do the decimals multiplication as well on the abacus, because a decimal is really just a decimal, because that's how we do it here, right? When we talk about it, the decimal sits between the ones and the tens, so it's not different per se. And we don't do fractions. If you do fractions, right? You have to divide that out, right? So it'd be 2 divided by 1, right? And then we have our decimal. Same thing. So when we do the fractions, we have to still work it out. So it's, abacus is not end all. Abacus is the gateway to complex math. There's a bunch of ideas and there's a bunch of framework to understand that really translates to other parts of math. Hey, quirky orc. You're hack. Glittering gammy. Okay. Does that make sense, Ethan? Worry warrior. Oh, thank you for the follow. Now I'm starting to calm down. Whew. It's been a little bit. It's been a minute. But yeah. Yeah, I mean, it's interesting on how everything is. But yeah, you could do decimals. You could do division. You could do multiplication. You could do adding and subtracting with the decimal. Same thing. Okay. If there's no more questions, Any last questions? Anybody else? Don't be shy. We're here. Okay. So if there's no other questions, I'm going to sign off. Thank you guys. Thank you again for following me and talking and chit-chatting. What happens if your answer has a decimal? Oh, you just move it up, right? You just move it up. So we're back to here. Let me rewrite this. Let me find another question. Oh, that was okay, hold on. Let me find another question. Let me see if I can find. Here is another one. Okay, so even if we work it out, I'll do it on the bigger abacus because then I have more numbers. Okay, so we'll do 85, 0, right? We'll do that. That's a 5. That's really poor penmanship. So the decimal would be where? 1, 2, right? The decimal would be here. So then that means we do 1, 2. So it'd be like this. So let me rewrite it. What if the decimal... Well, okay, you know what? Let's go back to this one. Sorry, I'm a little bit kind of mixed up. So let's do 7, right? 7.2. So if it's anything, then it'd just be up here. Just like, we just follow it, like everything else in like mainstream math. So here would have been 1, right? How do I know? Because it's 1, take away 1 is 0. So my starting point would be here. My answer would be here. And then I put my dividend here, 7 and then 2. So if you notice, my 1s is over here. My 1s is over here, so I will already have a decimal. So now I just work it out. So it'd be 1, right? 1, take away 7. So I still have more. Who is bigger, the dividend or the divisor? The dividend or the divisor? The divisor is still bigger. So I go over here and I take away, and 7 times what is equal to 20 or less? 7 times 2 is equal to 14. So I take away 1, take away 4. And then it just carries on, right? Now I have a remainder. So then it'd be like an R. So this question, this answer would be 0.12 remaining 6. That's what I would do. If that makes sense. Yeah. So you follow the answer here. Don't follow the answer here, because I was just writing to write. But you follow the answer that's on the abacus, because knowing where you start and you place your answer is what we start with. So won't it be hard if it's a big number? No, it actually would be a lot easier, because then you don't have to worry about the zeros and stuff. So even if it's bigger number, let me see if I can find a bigger number. So like, let's say about this. Well, this one will go out. Okay, so you know what? Let's do that one. So 3 divided by, what is it? 2794, right? So my starting point, what's my starting point? I have 1, 2, 3, 4, take away 1. So it's 3. 1, 2, 3. So this is where I'm going to put my answer. So what's going to happen, I would put my 2, 7, that's 7, 9, and then 4, right? So this is a bigger number. So what times 3? Who's bigger? The dividend or the divisor? The dividend is bigger. So I put my finger here and I take 2. So I take these 2. What times 3 is equal to 27? 3 times 9. So I add my 9. I take away 27. I still have, right? So then who's bigger? Dividend or the divisor? The dividend is bigger. So I'm going to use one column and I'm going to skip this column. So I'm going to put my answer here. What times 3 is equal to 3? It's equal to 9. Right? 3, I put my 3 here, take away 9. So I take away 9. Who's bigger? Dividend or the divisor? Dividend is bigger. So again, I put my finger here. Right? 3 times 1 is equal to 3. So 3 times 1 is equal to 3. 3 is a single, 3, take away 3. So again, now, do I still have any more? Yeah, I still have more. So what do? 3, who is bigger? The dividend or the divisor? The divisor is bigger. So I put my finger here. 3 times what is equal to 10 or less? 3 times 3 is equal to 9. And then it just keeps going, right? Now we're just in this redundant thing. But notice the way I have my answer. I have 931.3. So there is my decimal. But yeah, it's not that the number is bigger. It depends if what the number is compared to the divisor. That's what makes it more complicated. And then when you start going into division, it will get complicated quick because there's other rules that we need to understand. And I can talk about it, but it would get complicated really fast unless you know like all the formulas, then I can start talking about it. So I'm assuming that you're still a beginner, so I wouldn't go down the rabbit hole of understanding division. That's why. But the division with the decimals and stuff, it's still the same. It's just they have decimals, and your answers would still be on the abacus. Yeah. All right. Was there any other question, Ethan? Won't it be? Oh, wait. I'm just using a free website to learn abacus. Yeah, the free website to learn abacus won't go to the extent of the more complicated questions in division. Because those questions are far and few. So it's a little bit harder to find those questions. It does take a while to get to those questions and to build it out. Yeah. So like my kids, they do all the questions and stuff because we have a whole curriculum. And I have an abacus school. And then I have my whole curriculum, and we focus on like specific numbers and specific questions. In the free ones, they won't go as deep as I do, right? I mean, that's the difference between the two, because the free one is more just kind of like a general knowledge, whereas what I'm trying to do is I'm actually trying to provide a service. So, yeah. So yeah, just so you know, the ones in the free ones, you're not going to go too deep into it. So thank you for the hearts. Does anybody else have any questions? I'm not knocking the free ones. I mean, it's great to learn. But you'll get to a point where you get to numbers, but those numbers are really far and few. So, yeah. So I've been on for a while now. I'm getting kind of tired. I'm not as spunky as I first started off. But yeah, if there's any other questions, let me know. I will see everybody tomorrow. I'll come on board and see how everybody is. But yeah, I'm gonna sign off. But thank you again for everybody joining me. I know I'm going to be building my other books and stuff, and I wasn't sure if anybody would be interested in watching me go through my worksheets. What time will you be live? Follow me and you'll get notified. My schedule is a little wonky. So yeah, go ahead and follow me and you'll know when I go live. If there's any other questions. Any more questions? Going once? Going twice? Okay. I'm going to head to bed. It was a good one. It was a good one. Thank you for the questions. Thank you for the questions with the decimals and everything. Yeah, it makes sense. It's all just the same, really. What else? I think that's about it. I mean, yeah. I mean, it's just going through and understanding how to do the abacus. But yeah, Ethan, good luck with learning more about abacus. And yeah, if you get a chance, I would recommend buying a physical abacus if you haven't done it yet. I would recommend doing a physical abacus. The reason why is because then you could see the beads move. It's one thing to see it as 2-dimensional. It's another thing to see it as 3-dimensional. So, all right. So thank you again, everybody. I appreciate everybody that's still here. There's like 10 people. I'm thinking there's 10 people, but I'm not sure because I'm not sure like if this is like real time of the live metrics. I do know that it's a little bit wonky, but it is what it is. So again, thank you everybody for joining. Thank you for sticking around, and let me know if you have any more questions, and I'll see you guys in my next live. Have a good night. Real time. Oh, hey, hi from oh my God, from Chicago. It's like super late for you, man. That's like late. Did you want to learn how to do math on the abacus as well? 1 a.m. What? Oh my goodness, Ethan, you're from the Philippines? What time is it in the Philippines? 1 a.m.? That's still kind of late. If you want to learn about math at 1 a.m., I don't know, man. I'm assuming that, but that's what it is. 3:30 a.m. or p.m.? I think it's a.m. Or it's p.m. for you, right, Ethan? Oh, I couldn't sleep. Oh, you want? Oh, I can put you to sleep. Let me do some counting on the abacus. You know what? Let's do it. You know how to read the abacus, Eddie? Do you even know? Oh, it's p.m. Yeah, so it's like afternoon for you. How's the weather in the Philippines? Negative. Come on. Oh, so abacus. Abacus is a counting tool. It's a new form. Yeah, it's a new form of counting sheep. Let me show you. 1, 2, 3, 4. Yeah. You know what? Funny, Eddie, you've calmed me down. Like I'm not running high anymore, so I'm actually kind of calming down. So I might be able to put you to sleep. But yeah, like counting on the abacus. An abacus is a counting tool. So you know what? I'm going to continue. An abacus is a counting tool. Usually what we're trying to do is I'm introducing this to children. But I do notice now with the whole TikTok thing, it's great that adults are really interested in it as well. So I was going to expand it into like teaching adults as well. But the other thing is the children who learn abacus already knows their numbers. But what I did was I went one step further and I wanted to introduce abacus to preschoolers. So preschoolers are learning how to count. I wanted to get them to know how to count it on the abacus. Abacus is a counting tool. We can do adding, subtraction, multiplication, and division. And so that's my little thing. So then, you know, how we count it on the abacus, this is the horizontal bar. This horizontal bar is what tells us what the beads are counted. And so as the beads get counted, we do this. This is 1. So because this is 1, it's touching the horizontal bar. 2, right? 2 with the 2 beads is the horizontal bar. When we do 3 and 4, it's easy to see, right? Just like how we have a die, it's easy to see. But then we have no more beads to have the 5. The 5 is the top bead. The top bead will always be 5 no matter what. So we have 5, we have 5, we have 5, we have 5, we have 5. These are all 5s. But I'm going to move these up, and now we're at 0. How do I know? Because none of the beads are touching the beam. So we have 5, and then to do 6, we know that we have the bottom is the value of 1. So because the bottom is the value of 1, that will be 6. Then we have 7, we have 8, and we have 9. Then, because we have 9, how do we know what 10 is? 10, just like how we write it, just like this, 1 and a 0, 10 would be here. This is the 10s. This is the 1s, and this is the 10s. So we have our 1s, our 10s, our 100s, and our 1000s. And notice that in the abacus, we have these dots. These dots tells me where the 1s place is. And I chose the 1s place, and I'm fixing my camera, the 1s place over here. You can use this one if you like. Do you need to learn 5 pairs and 10 pairs? Yes, you do. You need to know that solid, because the 10 pairs and the 5 pairs is the fundamental of adding and subtracting. That's the fundamental of every adding and subtracting you do. you need to know your 5 pairs and your 10 pairs. You need to know the adding of the 5 pairs, and you need to know the subtraction of the 5 pairs. You need to know the adding of the 10 pairs. You need to know that the taking away of the 10 pairs. So going back to the counting, we do 10, 11, 12, 13, and then 14. And then we have 15, and I'll keep counting till you go to sleep, Eddie. We have 15, 16, 17, 18, 19, and then 20. Just as we write it, 2 and a 0. So we have 20, 21, 22, 23, 24. And then we have 34, 44, and then 54. We have 64, 74, 84, 94. So, Ethan, when you, thank you, you did great. I learned something totally new. Oh, good. But it didn't put you to sleep, though. Before I forget, Ethan, when you start learning your 5s, right? When you start learning your pairs, I would write it out. So I would like you to see it. So it's one thing to learn it on the app, right? But it's another thing to write it out. And when you write it out, the first thing is the making of the 5. You make a 5. You say 4 plus 1 is equal to 5. This is what we learn in school, right? 3 plus 2 is equal to 5. 2 plus 3 is equal to 5. 1 plus 4 is equal to 5, right? There's the opposite. Well, before we do that, right, we're going to do the other side. We have to isolate the variable. We do plus 4 is equal to plus 5 minus 1. Plus 3 is equal to plus 5 minus 2. And then again, plus 2 is equal to plus 5 minus 3. Write it out. When you write it out, say it out. When you say it out, it will get you to understand that there's a rhythm behind it, right? So you learn how to do the plus 5. After you learn the plus 5, you will do the minus 5. When we do the minus 5, think of it this way. Minus 4 minus 1 is equal to minus 5. Why? Because when we start to isolate the variable, we go back to taking it away. We do the addition. So if we want to minus the 4, we're going to minus the 5 plus the 1. When we minus the 3, it's minus the 5 plus the 2. See how there's the combination is the same, right? Minus the 2 is equal to minus the 5 plus the 3. And again, minus 1 is equal to minus the 5 plus the 4. If you know this solid, you will be able to do almost all of the adding. When you do the making of the 10, you need to make the 10 pair. Same thing. 9 plus 1 is equal to 10. The concept is the same, right? When we do it, it's plus the 9 is equal to plus the 10 minus the 1. And again, there's the opposite. Minus the 9 is equal to minus the 10 plus the 1. You know this solid, you'll be able to get everything. It just depends on how it all fits in. And that's what, when you go through the abacus and you go through the different numbers, you'll see that you'll find that there will be ways to do two-step equations. And so two-step equations is very common in algebra. And again, abacus is the gateway to complex math. This was perfect. Off to bed. Oh, yeah. You're welcome, Eddie. I'm happy you joined. I will see you in my next live. So, Ethan, does that make sense? And then now I'm going to go. Yeah. I'm wondering if you can use the abacus as skates. You know what? You could do skates. You could do a feet massager. You could do a back rub, right? Like a back rub. Or you could do a car. Yeah. Yeah, my kids were playing with it as a car. Because it's small. I mean, having it as a skateboard, it's a little... I think you'll break under your weight. I'm assuming that you're kind of heavy. So, all right. Thank you again, Ethan. Thank you, everybody, for joining. Thank you so much for talking and conversing. But I'm going to finally sign off. It's been about 2 hours now. And I think I'm time for bed. It was good. It was a good conversation. Thank you again. And I will see you guys all in my next live. I hope it was okay. Thank you again. Have a good Ethan, have a good night to everybody else. Bye.